Hello and welcome to MCV4U, or Calculus in Vectors. This is the introductory video lesson for this first unit, and the first unit that we're looking at is representing and performing operations with vectors. So the next couple of slides are they're pre-filled in for me, and the reason is it is review. So I'm just going to quickly talk about each. So what I would recommend is pausing the video, copying down what's on the screen, and then just listening to the commentary. So let's start off with just stuff that you already know. So algebra, for example. So algebra, it's just a process for solving an unknown with the help of variables, and the variable is what represents our unknown. So we're going to continue along with the theme of algebra that you've seen in the grade 9, 10, 11 course. So that hasn't disappeared. We're just going to look at it a little bit different this time. Moving along then, the bottom part of this page, there are a couple of mathematical concepts or properties that you've come to accept, and they're still going to hold true in the vectors course, and that's where we're starting, is with vectors. So for this particular example, we're looking at values of a, b, and c, and they are real numbers. Okay, so we're looking at variables a, b, and c. So if we look at the first property, the cumulative property, this is the property where if you have a plus b, it's the same as b plus a. So 1 plus 2 is the same as 2 plus 1. Okay. Similarly, order for multiplication, 2 times 3 is 6, 3 times 2 is 6. So that's a property of mathematical property that you've come to accept over the years. Next is the associative property. So if you have three terms that are being added together, so for example a, b, and c, if you add a and b together first and then add c, that would give you the same answer as doing b plus c and then adding a, or adding a and c together, then adding b. So again, a known property. Distributive property, very important with the algebra, and we're going to be using this actually we're using all of these properties in the vectors course. My emphasis here is that whatever you've learned already, the skills translate into vectors. So if you're asking yourself, well, how do I do this? The answer is it's exactly what you did in grade 9, exactly what you did in grade 10. So distributive property, you're multiplying b and c by a, the result would be a times b plus a times c. Okay, getting down to the bottom here, identities. If you multiply something by 1, it remains itself, so a times 1 is still a. And if you add nothing to a value, the result is itself still. And then the very, very bottom, we just talk about inverse operations. And for people that took the grade 9 course with me, you remember when we started into the algebra unit, we said solving algebra equations is just doing the inverse. So adding, subtracting are inverse operations, multiplying, dividing, and also squaring and square rooting. And you have a whole bunch of other ones now too. You also have, if you're taking the sine of x, the inverse operation would be sine inverse of x. Okay. Cube root of x, the inverse of that would be to cube it, and so on and so forth. You have exponentials and logarithms and so on and so forth. So all of those are being used or translated into this course as well. Problem solving skills, and this is something that I'm looking at this year in the vectors and in the calculus course. You're going to find that a lot more falls on your shoulders. There's no longer a recipe, so to speak. Sometimes you need to think out of the box, or sometimes you have to combine a couple of concepts. So there's so many things in this course with respect to how you can approach it that I can no longer say, okay, when you have a question like this, here's the recipe to do it. So here are your 4 basic skills to effective problem solving. So understanding the problem, you need to identify what you know, and more importantly, you have to identify what you do not know. There's a lot of people that will look at a question and they don't know what they're solving for, so it's very, very important that that's where you start in identifying that. Next is a plan. Like I said, there's no recipe anymore, so very, very important that you do your notes and you do your homework, because all of them contribute to different types of questions. So you need to associate it with a similar question you've done. Working backwards sometimes will help. And patterning. Okay, find a pattern in the system, and it'll help you out. Next is carrying out the plan. I cannot tolerate for you students leaving questions blank and saying I don't know how to do it. That tells me that A, you didn't do any of the homework, or B, you are not making an effort to apply yourself. You need everyone, if you're telling me you've done all the homework, then you should be able to give a question and an attempt. And then the final one, and I can't stress it enough, there is the star there, reflect on your solution. You need to reflect on your solution. Does it make sense? Does your answer make sense? So important. So many people will tell me that the balloon is deflating at 3 cubic meters a second, when in fact it's inflating, or the question tells you it's inflating. So it's so important that you ask yourself, does this answer seem reasonable? All right, so that's going to be the emphasis on the grade 12 course for sure, and I know it was in the previous math course as well. Okay, moving along here. Review of trigonometry. You really just need your grade 10 academic trig skills. I'm going to talk about the cast rule, and that applies more to calculus. So starting off here with trigonometry, you need to know your Pythagorean theorem, and yes, we will be using Pythagorean theorem a lot, all right, in the vectors portion of the course. Very, very important, and we will be using it in calculus as well. Okay, so we do need to know our a squared plus b squared equals c squared, something that can go on your first cheat sheet. Next is your right trig angles. Please make sure you've got SOHCAHTOA down pat. SOHCAHTOA, very, very important, especially sine and cos in the vectors course. And tan, for that matter, actually we use it quite a bit as well. You need to be able to label the triangle properly, and not only properly, but efficiently. This cannot be a stumbling block. So make sure you have your Pythagorean theorem and your right angle trig ratios all sorted out. Finally, you need your other two laws. You need your sine law and your cosine law. They both come up in both the vectors and the calculus portion. So you can see that this is a grade 10 theme as far as trig goes. And we're going to be dealing with sine law and cosine quite a bit. Sine law, hopefully more so, it's a little bit more simple. Please make sure that A, you know how to label a triangle properly. You put uppercase letters on the corners. So A, B, and C, okay, capitals are on the corners. And your lowercase letters, or your small letters, go on the sides that correspond with the capital across. So capital A, the side opposite it would be small a, capital B corresponds with small b. And that being said, here's your sine law. Now some of you will know the sine law upside down. It doesn't matter which way you know it, so you don't have to switch if you prefer it this way. Both are equally correct. One's not much better than the other in terms of this. Cosine law. Triangles labeled in the exact same fashion as it is for sine law, making sure you've got everything labeled. And really, I always tell people there's only one cosine law formula. It's the a squared equals b squared plus c squared, etc., etc. You do not need to remember the b squared equals the c squared, because all I do is erase the corners and adjust the triangle accordingly. Some of you will know the angle or the missing angle using this formula. So, angle A, that's going to be magic pen. Angle A equals the cos inverse of a squared minus b squared minus c squared over negative 2bc. You can put that on your cheat sheet as well, but it's really the first equation rearranged. I'm hoping by this level you're able to do that rearranging. All right. So just checking on my time here. Moving on to cast rule. Cast rule is going to be used in the calculus portion. We don't use it a whole lot in the vectors. A little bit off the start, but very, very minimal. So your cast rule again, your quadrants 1, 2, 3, and 4 are numbered accordingly, starting in the top right and moving counterclockwise for your numbering of the quadrants. Remember that the angle theta is measured from the x-axis always. So it's measured from the positive x-axis, and it rotates counterclockwise when we're talking about positive angles. So if we're talking about a positive angle, we were talking about a counterclockwise rotation from that positive x-axis. And then from grade 11 and also from grade 12, we know that all trig ratios are positive in quadrant 1. Only sine is positive in quadrant 2. Tan is positive in quadrant 3. And cos is positive in quadrant 4. And that comes from your basic trig ratios. And instead of having opposite over adjacent, adjacent over hypotenuse, opposite over hypotenuse, and so on and so forth, we change it to our coordinates. Okay, so the y is the y coordinate, x is your x coordinate, and the r is the hypotenuse, which never changes, and it's always positive. So down below here, I've already got that stated. So r is always positive. It's the length of the terminal arm. Length of a terminal arm is always a positive measurement. And your x value can be positive or negative, so it depends on which quadrant you are. If you're in the positive x quadrant, so if you're in quadrants 1 and 4, your x values will be positive. If you're in quadrants 3 and 4, your x values are negative. Similarly, whenever y is in the ratio, so whenever y is in the ratio, up here, if the y value, if it's in quadrant 1 or 2, the y value is positive. If you're in quadrants 3 and 4, your y value is negative. So that adjusts or affects whether a ratio is positive or negative. So one of your tasks here, the opening homework, is involving just going through and reviewing some of these concepts. So there will be some right angle trig, some Pythagorean theorem. You're picking and choosing. And then it moves into some 3D stuff that should have been part of the grade 11 course that you completed. So I will do a quick example with that in the next video, and then we'll move on to the concept in the first vectors concept.